Hello Casio CG50 users. In this video, really quick, we're going to take a look at how to use the binomial PDF function and the binomial CDF function on the calculator. And then the other video you watch will go into more problem solving. But just to use the calculator here, in a very large college, 30% of students are on the dean's list. I sample 15 college students at random. What is the probability that exactly 5 students will be on the dean's list? So the probability that x will equal exactly 5. So that is a binomial probability problem. So to find that on your calculator, you go to Menu, over here to Statistics. Once you're in here, you go to the same place you go to for normal distributions. You go to the distribution button, so F5. But instead of normal, you'll see we have another one down here called binomial. That's the one we want. We click on binomial, and we have 3 options. The first one, BPD, is the binomial probability distribution. That's the one you want if you want a single probability. That's what we want right now. The next one is the cumulative distribution function, if you want to add up a whole bunch of them, not just a single probability. And then the next one is the inverse binomial, which is going backwards, okay? But right now we want the BPD, the probability distribution function. Probability density function is what the D stands for. So F1. You want not to say list here, you want to say variable. So I'm going to click F2 to change the first one to variable. Now we can type in all our numbers. So I want x to equal 5. All right, the number of trials, so that comes from the problem. This one has 15 trials because we have 15 students. So 15. And now the probability of success, which is 30%, so 0.3. All right, we've got all that. You can hit enter one more, or you can go down here to execute and hit. And so we get about 21%, 20.6%. So that is how you can find a single probability on the Casio. All right, next, what is the probability that fewer than 4 will be on the dean's list? So that is the probability that x is less than 4. Now here we have to do a little bit of interpretation, because in the calculator it always has an equal sign. All right, it always includes the boundaries, where this one we do not want to include the 4. So we actually have to do the probability that x is less than or equal to 3. That's the one that we have to do. But we kind of go to the same place. Now in my calculator, I'm going to hit exit to go back. Exit to go back. All right, I'm back in my stats screen. I want to go to distribution again, binomial again. Now this time I'm going to be doing more than one probability. So I'm going to go to the cumulative density function, BCD, binomial cumulative density function, F2. So now this calculator is actually the most powerful of the other ones. This one gives you a lower and an upper now, just like for the normal CDF. So my lower in this case is going to be 0. And then my upper is going to be 3, because I want to include 0, 1, 2, and 3 in my probability. Number of trials is still 15. Probability is still 30%. Go down to execute, hit enter. So there is a 29.6% chance that there will be fewer than 4 on the dean's list. All right, what is the probability that 7 or more will be on the dean's list? All right, so now this one, what is the probability that x is greater than or equal to 7? Now this one has the equal in it already, so I don't have to do anything like the first one, because this boundary is inclusive, 7 or more. So I'm going to head back. Because I'm doing multiple probabilities here, binomial. This is again going to be the cumulative density function. So now my lower is going to be 7 because I want 7 or more. Now the upper, what is the upper going to be? So how high does this go up to? Well, there were 15 trials, so 15 is the max that it ever could be. You can't put in just a huge number here like we did for the normal. It does not go up into infinity. The most that we could have on this dean's list in my sample of 15 students is 15. That's the number I picked. So there you do have to look at the highest number possible. Hit enter a couple of times, and we get 13%, 0.131 as the probability. So that's how you can use the binomial probability density function, both the cumulative and the non-cumulative versions.